Hello, so I'm going to be explaining to elective 1, question 1. So here's our equation that we need to solve. First, let's draw a diagram of the real and imaginary axis to visualize the question. Here we can see that we're on the real axis. So let's replace our x's with z's. We can use the relationship that e to the I theta is cos theta plus I sine theta. So therefore our cos az becomes, the real part becomes e to the power of I az. So therefore we can plug this in and replace the top of our fraction with e to the power of I az. We now can calculate the poles for our equation using the denominator. So if we make these equal to 0, we have that z is equal to plus or minus 1, I, and z is equal to plus or minus 2i. Since we are only dealing with the upper half, we only need to consider z is equal to plus I and z is equal to plus 2i. So now let's calculate the residues of our equation. So first we have when r is equal to I. So we have the residue of z is equal to I equals the limit of z as it approaches I times z minus I over our equation with the z plus I, z minus I terms replacing the z squared plus 1 term. So we have z minus I twice, so we can get rid of this. This gives us with e to the power of a I squared over 2i times 3. And since I squared is equal to minus 1, we can get rid of the I term and make it e to the power of minus a divided by 6i. Now let's calculate the residue of the second part, where z is equal to 2i. So again, we have z minus 2i twice, and we can get rid of this. This gives us e to the power of minus 2a over 4i times 3. We can simplify the denominator here to 12i. We can now invoke Jordan's lemma and calculate the sums of the residues that we have calculated. So we have 2 pi I is equal to e to the power of minus a over 6i minus e to the power of minus 2a over 12i. Let's get rid of the 2 and the I terms from the denominators. This gives us pi times the brackets e to the power of minus a over 3 minus e to the power of minus 2a over 6. We can make these two terms have the same denominator by timesing the first one by 2. So therefore we have it all over 6. So our final answer is that cos of az over z squared plus 1, z squared plus 4 dz is equal to pi over 6, 2e to the power of minus a minus e to the power of minus 2a.